Do you tend to work in the office here?
All right. All right. Hey everyone, I'm Pete. I'm a web developer and also do a lot of graphics, like games and that. Around Wollongong, I've done some work with Deviga and some of the VR stuff. And I just want to share a bit about what I've been doing with with web and the graphics and some of the experiences I've had. Yeah, so graphics are cool, you know, like it's not showing up well here. I swear it's working well on this. You know, they're interactive, so you know, I wouldn't bother to do that. But you know, for example, this is running just completely on the GPU. Like people are able to do really weird and creative things just using using the GPU instead of regular CPU stuff, and it can be a pretty fun world to get into. For me, I tend to think of things in three different categories. The first one would be like you know, functionality. You know, you see like people will say, hey, I want to put some 3D graphics on my website for a purpose. You know, I've got a reason. I was in Campbelltown the other day. I was like trying to find this restaurant, and I saw that there was this new button on Google Maps that, you know, lets you overlay it with the 3D world. And I was like, oh well, you know, that was a lot easier. I could suddenly just put on my camera and I could just, you know, see where I was going. So there can be a functional aspect to 3D sometimes. The other reason might be for you know, to make your website a bit more exciting. You know, sometimes people want to use a bit of WebGL to you know, for a marketing reason, or you know, to make things a bit more interesting. It could be like every time you visit the website, it'll be a little bit different. It could be like it's going to render stuff depending on some data that's coming in. So sometimes you can have people saying things are functional, but really that for a marketing reason, you know, like stuff like order your pizza on the metaverse or something like that. You know, be like, okay, like you're saying it's functional, but really that's a marketing thing. So I mean, you know, it's a valid marketing thing. Seems to be something people are doing a lot of these days. And finally is for creative reasons, like for games or creative coding, you know, generative art, these sorts of things. I've seen like the tools that you'd use to do generative art for creative coding tend to be a little bit different to the ones you use to make a game. They're just slightly different purposes, but you know, we might have a look at that further on. Oh yeah, and this is something to know. This is like a live coding. You know, you have like a DJ, and then some people would be doing some like live shader work. You know, depending on like how the room's going. Fun thing to do. Okay, so let's say you wanted to get into 3D. Like, how would you get started? So this is a script that's going to add a web component to your HTML, and then you can sort of use the model viewer HTML tag, and that will it's probably the closest thing you'll get to like a 3D equivalent of like an image or a video on the web. So you can see it's just pointing to that's a 3D model, and yeah, then you can sort of, you know, you can drag it around and, you know, zoom and that sort of thing. So I mean, so that'd be good if you just wanted to render a model. You don't need to do any extra coding for that sort of thing. You can just get it going. But if you wanted to get things a little bit more, you know, you might have a reason for making things a bit more, you know, interactive, or have some custom setup, then you're probably going to need to use a framework. This is an area that I'll probably spend a bit too much time bouncing around. Like, I started off with Unity, that's sort of like a native game engine, and then I moved to the world of the web, and you know, I fell in love with doing web technologies. Went from Tree to Babylon, back to Tree again, and now I'm working on Bevy. So I mean, like, you know, they've got similarities, but they've also got some important differences. And I've categorized them in these three categories. They're pretty broad sort of categories. I guess this is sort of like at least how I think about them. So first of all, you've got these are sort of native first engines that also target the web. So yeah, so Unity and Bevy. Unity is like C++ and C#. Bevy is Rust, and they're going to be, you make a native application, but then you set a flag when you're compiling or exporting, and then it'll also go to WebAssembly. They tend to be bigger because they're using non-native like APIs. Let's say like their audio engine or whatever is going to be a non-native thing that they're sort of like can be shoehorning into the web. They can be bigger. They can be a bit more performant because well, it can be. Like you got to take all of this with a grain of salt. Because you're in the WebAssembly world, which means you're able to do some things with memory layouts. You don't have the JavaScript like garbage collector just running whenever it wants, that sort of thing. But at this point, WebAssembly doesn't expose the WebGL API, so everything's going from these WebAssembly things sort of through some of those JavaScript APIs to the renderer or to the GPU. So it's a bit of a funny world at this point, but you still have these options. And second of all, you got these are the JavaScript first frameworks. These are the ones that were built on the web for the web. They're going to be the smallest ones. If you're worried about size, they're going to be the ones you're going to be looking at, just because they're already using the native APIs. 3JS is by far the smallest. Babylon's quite a bit bigger. It's a bit more targeted towards what do you call it? The bigger companies who need something a bit more stable. It's also Babylon.js has more bells and whistles. It's got like a bit more of an editor experience if that's what you need. And finally, no code. So Play Canvas is kind of in between, but you can get away with deploying something without doing any coding with Play Canvas, and something like A4, if you said hey, we don't want to roll up our split, we don't want to get too into all this. We could just sort of take something off the shelf. There are those options as well. Yeah, so I mean, I've just written here your language. You might want to consider what language you're already using in your house, or what you're already familiar with. You'll probably find a 3D framework that suits that, because there are so many. And there's also paradigm. This is something that I've found. I've had some experiences where trying to match, for example, something like Bevy. If you take this WebAssembly world and you need it to talk a lot to a React world, you're going to end up doing a lot of binding work, and it can get a little hairy. It can be done. I guess it depends on how much those two layers sort of need to interact with each other. Yeah, are there any questions at this point?
In a React world, what kind of element does it deal with? Is it a canvas?
It's a canvas. Yeah, absolutely, yeah. Yeah, it is a canvas.
If you could pass a render to Bevy, and then we just deal with the canvas directly, if you rendered it in React.
Yeah, that's right. If you rendered it in React, you'd do a little bit of work to make sure the canvas was sitting the way you wanted it to, and then you'd hand off all of it to Bevy. I don't have a whole bunch of experience in how you get, for example, data out of Bevy. I guess you could do that. You'd start writing those. I guess it's like any WebAssembly. You'd start writing those WebAssembly bindings. You'd probably have better luck doing that with Bevy than you would with Unity, because Unity really is a beast of a thing. It's going to be that's very much native first. That also deploys to the web. Unity had this project Tiny where they said, hey, we're going to deploy to the web, and it's going to be really small, it's going to be great, and then they canned it. So hopefully they'll bring that back. Are there any other questions at this point?
And any of those programs take the globe and then a data set and then put that on the globe and then take another set and animate?
That's an interesting question. So you have some data.
Yeah, two data sets.
Yeah.
There'll obviously be one will be different than the other. They'll give the impression the globe is spinning for the sake of argument, or the data sets will be globe is still and data sets moving. And can that do that? Can any of those do that?
Yes, I'm sure. Well, I mean, you could think of what these are doing as you can get as low level as you want. You can think of them as just wrappers around WebGL.
Yeah, right.
So let's say you like got like a sphere and you had like a texture that you put all the data onto the texture and just fed that to one of these programs.
And all of those will do that?
Yeah, I mean, but they're not all equal. So let's say you wanted it to be as small as possible. You were deploying to the web and you wanted it to be something that everyone could like have access to really easily.
Well, the data set's 75K. It's a KML file.
Okay. And here's another question. Are you only deploying to the web, or do you also like to do a bit of native?
It's a very interesting thing. We would like to put it on the phone and tap your iPads and stuff like that. When you're finished, I'll show you like an example. But I'm just asking a question.
Yeah. Okay. So I mean, I'm sure that either of these, like some of these, could be up to the task. Another thing that's coming to mind, and I'm not sure if it is possible. There are like data visualization frameworks as well. So there could be something that's really tailored towards like a specifically like it's like scientific data or something that could be a better fit. But it is a good question.
QGIS will do it too, but I think it's a bit cumbersome. I'm talking to my brother about that. That's why I was interested in this here. It was simpler.
TechGL, scripts,
Right.
visualization, like really do a lot of 3D.
Right.
Cool. Okay, so at this point, I was thinking that like we could either pop the hood on WebGL and have a bit of a look at how that works, or we could have a look at some of these frameworks a little bit deeper, or we could just like I don't know, have more questions. I don't mind. So like, who would be more interested in like for example WebGL, getting into how that works? Okay. And compared to that, who would be interested in like just looking at some of these frameworks and the differences between them?
It's up to you.
We'll do both. I'll be here all night.
Are they all just not WebGL?
They are all WebGL.
Underneath everything.
Underneath everything, they're all going to be using some similar WebGL commands. That's right. Yeah. Okay. How much time have I
Charge you
got?
for everyone.
That's a good question.
Just charge you for everyone.
Can we do a shader party?
Yeah.
Like you said. that looks exciting. I'm like,
Which one?
can you do a shader party?
Shader party. Yeah. I mean, I could. We could do a live coding thing if you're into that. Yeah. Okay. Look, I'll breeze through these. I don't have nice things to say about Unity right now, so I won't. I'm doing a lot with Bevy at the moment. I just find that it's an interesting technology, and yeah, I'm learning Rust and having a lot of fun doing that. It uses an ECS architecture, which I'll briefly talk about. We got this problem with engines like Unity, and I guess with some of these the way that you lay out an application can be really important when you're going for 60 frames per second or like 120 in the case of VR. And what this paradigm called ECS attempts to do is lay out everything in memory as nice as possible for the CPU. So you've got this thing called indirection where the CPU will say, oh, okay, go into the player object, oh, but now I need to find the position, and now I need to find its health, now I need to find that, and it does a lot of jumping around, which can make things really slow. And what ECS attempts to do is says, oh no, I know that you need these components, and I'm going to work them all at the same time, and it's going to lay it out in memory in that way. So you can get performance out of it. It won't necessarily be more performant on the web because it's the whole WebAssembly thing. It's like, is it more performant than JavaScript? Sometimes. It depends on what you're doing. But yeah, I'm having a lot of fun learning Bevy. React 3.5 is also a really interesting technology. I only discovered this like a couple of months ago, and I was kind of blown away by how easily you can integrate this with your existing website. So just like React DOM and React Native React renderers, right? Like React in and something out. This is a renderer where it's React in and 3.js out. And so yeah, you can do really interesting things like, you could say like if, whatever, then render this, if whatever, then render that. It's a really different way of thinking about doing 3D development from, well, it's not different for web developers, but it's very different for game developers. So that's been a lot of fun to learn. Of course, you don't want to do some things at 60 frames per second. React was never designed to render at 60 frames per second. So they have these like hooks which will allow you to do like your animations as you need to. Yeah. So anyway, so that's another really fun technology. Are there any questions at this point? Oh, computer. Okay, so that was the WebGL stuff. I don't know if we want to get in the weeds of that. Try to give an
Quick
idea.
rundown of what WebGL is for those of us who have not done anything in 3D before.
That's a really good question. WebGL, some people tell you it's a 3D engine. It's not. It's a rasterization engine. So the best way to think of it is rasterization, this idea of like, say, like pixel, 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 does that really, really fast.
Can we get a t-shirt with that on it, please?
Yeah. I mean, I always think of like you got those old CRT monitors, and, the slow-mo guys will do like a video of like rasterizing in slow motion. But it's the way I sort of think about it. So you start with a mesh, you start with an object, a description of a bunch of points in space, and a way to link between them. And then we have what's called a vertex shader, which will then say, okay, I'm going to take all of those points and I'm going to flatten them into a 2D screen, and then give that back to the GPU. GPU is going to have a think about it, say, well, this one's behind that one, so I won't use that. This one's covering this pixels, and I do need to render that. And it's going to give you back control in what's called a fragment shader. And the fragment shader is where you decide what color to render to the screen. There are three sort of primitives that you sort of think about when you're doing this work. There's uniforms, which is the same for every vertex. So that would be, for example, the position of the entire mesh, or like some tint you wanted to give the whole mesh, or the texture that you're using. Same for the entire mesh. And then there's like attributes. They're for individual vertices. So that would be like the position of the vertex, what's called UV coordinates, which lets it know how it's going to render a texture. And there's also things like colors or custom attributes. So for example, if you wanted to do like a particle system, you could say, I'm going to pass like some random position in space to the vertex shader. And then on the GPU, you're going to do some work to turn that into a little particle. So you can do whatever you want, but that's generally how you write your normal shaders. And finally, varyings. That's just how you get something from the vertex to the fragment shader. And all they do is interpolate between values. So that means like, let's say you got this vertex is like blue, and this vertex is green. Then when it draws this one, it's going to be somewhere between. It'll be like cyan, whatever. It'll be like somewhere in between. So the GPU will do all that interpolating for you. Okay, so this is sort of how you would get into that. You would start by describing your vertices, just positions in space. These tend to be, we tend to think of them as buffers, like one, float array of buffers, or floats, or U16. So like you want to sort of make it as easy as possible to pass things between the GPU and CPU. So this is describing a plane, some points in space, and then this is describing how they're linked together, called indices. We're always drawing triangles. So for example, 0, 1, 2, that's this triangle, and then 3, 2, 1 is this triangle. It's important how they're wound, they call it winding, because then the GPU knows whether it can throw it out. like for example, you've got a 3D object, right? Then it's gonna know this is facing forward, but the one behind is facing backwards, so it won't even try to render that. It'll make it a little bit easier on the GPU. And then finally, this is a uniform. So these are your attributes, and this color down here would be like the color for the whole mesh. So that'll be a uniform. Okay, so this is a shader. This is a program that runs on the GPU for thousands of vertices or thousands of pixels at the same time. So it can be a little bit of a different way of thinking about coding from CPU coding. You don't have things like, oh, I'll just put this variable here, which they can both use. It's a bit more, what they call parallel computing. So everything's running at the same time. So you just got to keep that in mind.
Do you mean that it's multi-threaded? Is that what you mean? Or?
Yeah, you could think of it like that. Yeah, it's like 1,000 threads at once. That's right. Yeah. So right now, for every pixel, it knows how to render them all at the same time. Definitely. Okay. So yes, you got the attributes for each vertex. You've got the uniforms, which would be the same. So this would be the position. The matrix would be the position of that mesh. And then to get to get this vertices position, we were talking about take a vertex in 3D, make it 2D by multiplying the matrix by the position. And you don't really need to know all this if you're just trying to do some fun stuff on the web, but this can be really fun. This is where you're gonna, if you're working with shaders, it's where you're gonna put something in and get something really weird out, because you've got all this, the power of the GPU. It can be a really interesting place to play. And then finally, we've got this color that this is a varying, so this will be passing that from the vertex shader to the fragment shader, and then finally you're spitting out some color. So yeah, so on the fragment shader, this is where it's only going to call this for the fragments or for the pixels that it needs to draw, and it's going to take this varying color and then just pass that out. I mean, you can do whatever you want in here. You do very interesting and fun things in there. Some people would only write fragment shaders. So there's this whole website called Shader Toy, where they just write fragment shaders. They don't worry about the vertex side of things. They just say okay, given doing everything at once, what kind of mathematical equations can I put in to get some beautiful object out? So that's also a thing that people get into. Okay, and I'm showing you this just not so that you do it, but maybe so you don't have to do it. This is the WebGL API. So all of those frameworks are all doing something like this. It's very verbose, and it's very it's not something that you sort of get into if you're trying to get something done. It can be fun and it can be a great learning experience, but it's more just for you do it for learning rather than for for production. Anyway, I just thought I'd show that. Are there any questions at this point?
So most of the frameworks just interface with WebGL for you, just take that pain away.
That's exactly what the frameworks do. So they will do something like this, and they'll make an abstraction that makes sense for us as people, and so that we don't have to think about state. This sort of has to happen every frame, or something like this has to happen every frame, and instead we can say something like, I'll just move the position, and this is the Unity version, just move something and then it'll do all that for you. Yeah, that's right.
What's the relationship between WebGL and OpenGL?
Well, WebGL is based on OpenGL ES 2 or 3. So the mobile version of OpenGL is what they designed the WebGL spec on. So actually, if you know any OpenGL, this will look quite familiar. So you'll recall it's very similar. And if you do end up learning WebGL, you'll probably use some OpenGL resources to learn.
So that begs the question, should you learn WebGL or save a shitload of time and learn something like 3JS or something that abstracts a lot of this away?
Yes, that is a good question. And I think this is sort of, I guess, what I'm hoping to demonstrate here is this is 3JS. This is the abstracted. Well, you don't have to write your own meshes. Usually, you'd import it from an artist, but you can get super low level using the frameworks. All of the frameworks will support writing your own shaders. It's the WebGL is like the state machine, like weird part that I don't think it's really for regular folks to get into, unless they're doing it for educational purposes, which can be really fun. I do have a resource at the end for people who are just curious to have a click around and see like how it all does get put together.
So I dipped my toes into like a 3JS course some time ago, and we didn't end up going through with it because we just had too much other stuff on. But I was right at the beginning, and the guy who's like doing the course was like, if you wanted to just make like one triangle in WebGL, he was saying it takes like, I don't know, 80 plus lines of code to write one triangle. Is that fact or?
That's a fact. Yeah.
Yeah.
Yeah, it is a fact.
That would be really fast afterwards.
Yeah.
So, Simon's course.
Yes. Yeah, it was actually. Yeah.
It would be. Yeah.
Is the terminology the same between all of these programs? Another, the basic terminology and instruction set. So when you're talking about it, one in meshes or GL, you're talking about the same thing?
Pretty much.
All right, okay.
Yeah. Oh, yeah. All of them will talk about a mesh. They'll all talk about a material, which is like, how you style the mesh. So there's going to be slight variations. Like 3JS uses something called a geometry, whereas Unity doesn't. So there's slight variations, but they're pretty much identical. Where they really differ is one level of abstraction higher,
Right.
and that's like how you think of the objects themselves.
It's going to have different jargon and different language, yeah.
Yeah. I mean, they tend to be built in certain ways. Like, for example, 3JS doesn't really have an idea of like a game or components or like behavior. 3JS says we're a 3D rendering library and we let you decide the rest. Whereas something like Unity will say like, hey, this is a game object. You have a component with behavior on it, a lot more opinionated.
And so WebGL is just the people who like self-flagellation. It's just a form of self-abuse.
I wrote a WebGL sort of framework using assembly scripts, and it was less painful than you'd think. I think just because this stuff is really known. This is stuff we've been doing for decades in native and open and native and web, and so the resources are really good. Like the tutorials are awesome. And I don't know, there's something, it's like coding, isn't it? You're doing things one little bit at a time. Oh, this works, oh, that works, There could be something nice about it.
Have you run into a situation where you wanted to do something 3, for example, you couldn't do, you had to go, actually, I need to go to WebGL for this?
Never.
The API is not sufficient.
Never. Just because 3 will let you write your own shaders, write your own meshes, pass your own data to those meshes. So all of them will let you get as low level as you really need to. Sure. Yeah.
I might have missed it, but you mentioned the difference between the compiled language in the first column that you mentioned before, and then the JavaScript version, etc. Why would you use one or the other? Like, if you want to build something for the web, you will always use the JS library, or what would decide what you use?
Yeah, great question. Great question.
Is that because of performance? Is that because they are compiled? What would drive me to decide one or the other? I don't know anything about this, so it's the first time I've heard it. I haven't seen it, but yeah, it's interesting.
Okay, yeah, absolutely. So one thing that might drive you one or the other is the language you're using at your team. So if your team is using like Blazor or C# World, then something like Unity would make more sense. It's like, okay, we stay with C#, guys. We love C#, right? Or if you're a JavaScript only house, if you really were like all we do is React, then to say we're going to add, like Rust to our stack, that could be a big commitment. So I guess that would be one of the considerations. Another one which didn't really touch on was artist tooling. So let's say you were making something that was really important for you to allow non-technical people to roll up their sleeves and get into. Then some of these are going to be easier for them to do that with it than others. For example, Babylon.js has a bit more of a mature editor, so that'll be another consideration.
Okay. So for me, there is no reason why not to use the JS version. For me personally.
Usually, yes. Usually, I feel like the JS version is the most sensible.
So it's not slower. It's
not for real world stuff. And again, this is like this WebAssembly thing where they'll say like in really specific cases, then WebAssembly could be faster, but in the vast majority of cases, it really like another way to think of it is if it takes you 10 times longer to write it, that amount of energy could have been spent on optimizing the JavaScript. Is something like that, and especially with graphics. So sometimes I don't remember that, but yeah, definitely going with the shorter path of least resistance would be a great idea.
Thank you.
Any other questions? Okay. Well, I'll probably just get off the stage. I do have some demos and stuff. Maybe I can do that afterwards. After you guys. Thanks, man.